Hello and welcome back. I hope you guys are having a good day. Keep in mind tomorrow is Friday, so we almost are here with the weekend. We got a 3-day weekend because we got Labor Day coming up, so we don't have school on Monday, which is wonderful. So if you guys have fallen behind, you can get caught up. I do want to encourage you guys to stay current on the assignments so you don't fall too far behind. I know some of your classes are probably front loading everything at the beginning of the week, and then you feel like you have the whole week to do it, and then everyone gets behind, and then you try to knock out 5 math assignments and lectures and everything in one day, and that's just not going to happen. Let's be honest, you're not going to watch all the videos. You're just going to skip right to the problems and try to catch on and figure out what's going on, especially because you guys don't have textbooks. It's not like you can read the chapters right now. So you really got to go through the lectures and make sure you're gleaming as much information from what I'm saying as you can. So you're not going to learn just from working the examples and the problems, okay? So make sure you're watching the whole videos. Today should be really short. We're going to talk about Simpson's paradox, and we're going to revisit the Titanic again. We'll probably revisit it again later in the year because it's fun to look at. We're even going to talk about sneakers and jeans as well. So the question that we're going to look at today, when we looked at yesterday, was there an association? So did your ticket stub, your class, did that impact or have an association on whether or not you survived? Now, if it was fair, then we would expect if there was no association between those, which we would say if they were independent. So is class independent of survival? Then we would expect every class to have the same or close to the same survival rate. If the overall survival rate on the Titanic was 32%, we would expect all of the classes to have a 32% survival rate, or close to it, because it's not going to be exact, right? There's always going to be variation in sampling. So we'd expect 32% of first class to survive, 32% of second, third, and the crew as well. That's what we're talking about. We're talking about an association or independence. Today, we're going to look even deeper into that, but breaking them down into groups, not just by class, but also men, women, and children. So we're going to see, was it just strictly the class that had to do with survival, or did they really actually give up their seats, including first class men, for women and children, so that they could try to, I guess, survive hypothermia in the frozen Atlantic or something longer than they would expect women and children to survive, or something like that. It just, I guess, the chivalrous thing to do. But I've been told chivalry is dead. But anyway, this is back in like 1911, I think, something like that. So maybe 1912, I was close. Maybe chivalry wasn't dead back then, and that's what we're going to find out today. That's kind of our investigative task. Anything else I want to say about Titanic? Oh, one more thing. A lot of the survival actually had to do with where they were sleeping, because the incident happened at night. So first class would have their cabins would be closer to the deck. So they would be the first ones to the deck and the first ones to the lifeboats. So the reason we saw more survivors from first class probably had to do because of the location, right? If you were in third class with the crew members, they slept in the cramped quarters where no one wanted to be, or the very bottom of the boat, which means they would have to travel up a lot of stairs to get to the deck, which is where everyone would want to hang out anyway. So that's why a lot of people, crew members and third class, maybe didn't even have the opportunity to get to the deck, which is kind of sad. But or by the time they got there, the lifeboats were already gone and full, etc. But did they try to do women and children first? Well, let's find out. All right, first thing we're going to do, though, is we're going to look at jeans and sneakers. Now, I thought about this. Usually we would, right now, we would have everyone in class, and I would have you figure out where in this contingency table you belong. So are you wearing jeans? Are you not wearing jeans? Are you wearing sneakers or tennis shoes, or however you identify sneakers? Or are you wearing some other shoes or some other non-jeans, right? Like right now, I'm not even wearing shoes. I am wearing pants. That is important, but I'm not wearing shoes. So this probably wouldn't work if I sent out a survey to you guys, because yeah, that's why. So what we're going to do is we're going to use the data from last year. So last year, of my 30 students, I surveyed them and wrote down who was wearing jeans, no jeans, sneakers, no sneakers, and all the combination of those two variables. Okay. So here's our data. If we look at the percentages, if we want to know, are we taking a percentage of the columns or of the rows, just look where the 100% are. So this tells us that 59% of those who were wearing jeans were wearing sneakers, and 41% of those wearing jeans were not wearing sneakers. So these are going to be the conditional distributions of sneakers depending on of those who are wearing jeans, whether or not they're wearing sneakers. Okay. And then for those who are not wearing jeans, 62% were wearing sneakers and 38% were not wearing sneakers. or sneakers and not. You know what I'm saying? And then the overall marginal distribution over here, 60% of all my students last year were wearing tennis shoes and 40% were not. Okay. What would also be kind of fun is if you were looking at just wearing tennis shoes and sex as well. So were women more likely to wear shoes that were not tennis shoes, right? So like wedges or flip flops or something like that. Probably so. But anyway, that wasn't what we were investigating. But these are kind of fun things that we could have done instead of doing jeans and sneakers. But it's kind of cool. So that's our data for that. Make sure you know how to break down the tables and read the conditional distributions and the overall data that we have. You could do the conditional distributions across the rows instead of vertically on the columns. Either way, if we graph this data, we can visually see what those whether or not we believe there is association once we look at the graph. Okay, but overall, if I look here, we could also do it here. So like survival rate, let's look at sneaker rate. So of those, the overall 60% of my students were wearing sneakers, right? And then the jeans rate for those who were wearing jeans, 59% were wearing sneakers, and those who were not wearing jeans, 62% were wearing sneakers. Now, are all three of these exactly the same? Remember, this is just like our survival rate. 32% survived overall, then we had varying survival rates depending on class, right? These are not exactly the same, but we would say they're close enough, or there would be no evidence or weak evidence of an association between jeans and sneakers, at least from this data. If we did it this year, we'd probably find out that you guys aren't wearing shoes, which would be, we wouldn't find out anything, pretty much. All right, so Simpson's paradox. If you will have some problems to work about, breaking down those and making sure you know how to do the percentages. Please, if you're having any issues on those, I have the solutions typed up. So just shout out in Google Classroom, just on the private comments for the assignment. Just ask me, hey, Mr. Murphy, can you show me how to do number 2 or number 3 from the front side of assignment 2-3, and I'll get that to you. Then you can. I've typed out how I mentally go through the problem and set it up so that you can really, hopefully, I think you'll find, make it easy for you to understand how to do it if you weren't sure about it, because you can't really check your answers in the back of the book until you have the book. Okay. All right, so the next part here about UC Berkeley, in 1973 there was an allegation of gender bias among admissions in UC Berkeley. So this is actually an example of Simpson's paradox, and you can read the bottom half of the front page if you want to see in more detail, and you can kind of slow it down and really understand hopefully what's going on. So they looked overall of the applicants, of all the male applicants, 44% of the men were admitted to UC Berkeley, but only 35% of the women were admitted to UC Berkeley. So that is, we would expect those to be about the same, like survival rates, right? If 44% of the men survive or were put on a lifeboat, but only 35% of the women were put on a lifeboat, we'd have problems with that, right? So it looked like that's a pretty large discrepancy. So there was an allegation of gender bias. And so this is actually an example of Simpson's paradox. We got to be really careful. So a closer investigation by college department, or colleges is actually what they call them in a university. So like the College of Math and Science or whatever, they actually found a different story. Whenever they looked at instead of overall men and women, they broke it down into each group. And so over here we have A through F. These are different colleges, and they tell you the number of applicants and the percent that were admitted by men and women. And I highlighted the fields that had the higher admittance rate. So for colleges A and B, there were actually a higher percentage of women that were admitted to those than there were for the men, who had a little bit lower, or quite a bit lower. And then in this college there were more men, but it was close. Here more women were admitted, and this college more men, but slightly. And then here it was almost a toss-up. So there's a different stories kind of being told when we break it down by college. And actually what they found is that women on average had a higher admission rate than men did. But when we broke it down by college, but when we looked at the overall acceptance rate for men was higher than the overall acceptance rates for women. So why are there two different stories being told? And this is why it's called Simpson's paradox, because it seems kind of like a contradictory thing. Well, what they ended up finding out, and you can of course read it yourself, is that women were applying to colleges that were much more prestigious, and they had a lower acceptance rate, like medicine, and I don't remember what the other one. You can read it yourself, I guess, but medicine, and law, right? Okay, so that makes sense. And men were applying to fields in general in higher numbers that were less prestigious. Apparently, engineering at UC Berkeley is not that prestigious. In chemistry, okay? So the reason that the men had overall higher acceptance rates was not because of gender bias, but was just because of the different fields that men were choosing to go into instead of the women. And so when they broke it down by each college, they actually found that women had a higher, slight, but albeit it was higher admission rates on average than the men did, which is interesting. So anyway, that's Simpson's paradox. Not super important. You won't see anything like that on the A/B test or anything, but I thought it was interesting. I thought I'd share it with you. So with statistics, there can be, if you look at just the overall generalization, you know that looks bad. But if we look deeper into it, we investigate with statistics, it told a very different story. So kind of cool stuff, and you can kind of see how people can use statistics to lie and to deceive people. And if you knew that was true and you still chose not to report what was actually going on, and you just ran with this story, then that would be, bad practice of statistics. And unfortunately, we see that all the time. Do I sound sad? I'm not. It's almost Friday. I'm happy. All right. And yesterday was a really fun video for me. That was a lot of fun. So is today. The Titanic is kind of this is cool stuff. I enjoy it. All right, so we're going to look at distribution of survival by class, which we already did. Okay, these are the survival rates across the class. Okay, so 32% overall, and then the crew didn't have as high of a survival. Third did not have as high as a survival rate, and first and second class were higher than we expected. When we graphed it out, the survival rates were going down, which meant the death rates were going up. Of course, those two have to be the complements of each other. So if this is 62%, that means that this is going to be 38%, right? They have to add up to 100. So if we just graph the survival rate, which is the blue one, then we wouldn't have to graph the death rate. We're going to do the exact same thing with the information that's in here, broken down first class, second class, third class, and we're leaving off the crew here because you wouldn't have children in the crew because child labor laws. But anyway, you get the idea. And so you look at that information. All you need to do is find the survival rate for each one of those. So there were 5 children, first class children altogether, and 4 survived. So 4 out of 5 would be 80%. Okay, so you fill in 80% there. And then there were 139 women in first class that survived out of 143. So find that percentage. Okay, once you have the survival rate, you automatically have the death rate, so you don't even have to worry about filling it in. Like, we're only going to graph out one of these, not both of them. It's not necessary. We can get the information from it. Okay, and again, one more thing I want to point out is that we would have expected all of them to have about a 32% survival rate, which would be a line that kind of looks, actually, I can do better than that. I think it is not 2 but 4, 5. Okay, yeah. So we would expect an overall rate about 32%. Okay, so we have deviations from that. Some are higher and some are lower, right? And the same thing we would expect across the board, everyone to have about the same if it didn't, women and children were not actually given preference. All right, so go ahead and fill that in. Do that. I mean, you got some calculations you got to do. I hope it would be easier if you had a calculator, but I know you all have the apps on your phone. And for what we're doing right now, that's not really that big of a deal. You'll end up filling in a chart that looks like this. So you're going to graph the survival rate for first class women, children, which we said was 80%. So you go up to 80 and you fill that in. For the women, which is going to be, I believe, a little bit lower than that, maybe even higher. And then the survival rate for men for first class. Do the same thing for second class and the same thing for third class. All right, so that's it. I'm going to leave you guys to do that for the homework. Whoa, dude, knocking this out in like 14 minutes. You're welcome. So the spoilers, I am going to show you the charts in case you're not actually doing the assignment if someone else watched this video or something like that. Didn't really expect that, but if it is, I'm going to go ahead and show you the data so you can see the story that it tells. The big question that we're trying to answer, again, did men, even first class men, have a lower survival rate than women and children that were third class? So did first class men excuse me, even though they were the first ones to lifeboats, did they give up their positions even though their family was put on the lifeboats to allow the women and children from even third class from the bottom of the boat to get and take those positions? And then Jack died at the end of the movie, which is a terrible movie. You shouldn't watch it anyway. 3 hours of your life will never get back. 3.5 hours, just terrible. Anyway, and the Mythbusters prove, of course, they both could have fit on there, and so he died needlessly. And I think that he died because he actually didn't want to live the rest of his life with her, because she's annoying. Let's just be honest. Okay, anyway, so spoilers. Go ahead and fill that in, and you'll find out the answer, which is going to happen in 5, 4, 3, 2. I don't know why I'm counting down. You get it. All right, so here it is. So first class children, women, and men. Second class children, women, and men. And third class children, men, and women and men. All right, so if we look here, the survival rates for women and children are higher for every class than the survival rates for men. So they were chivalrous, at least back in 1912. And the men, even the first class men, okay, had a lower survival rate than the third class women and children. So even though there were even more women and children that didn't even have the option to get to the lifeboats, whenever they did get there, you had first class men who left their families who were already in the boats and gave up their spot for third class women and children. What a beautiful story that the data tells. I mean, this is awesome, right? I haven't lost hope in humanity yet. But that's just so cool. There were more that did survive than, of course, the men of second and third class, of course. But it is nice to see that the first class men did give up their seats for the women and children that came and arrived to the lifeboats later after they did. So a happy story and a happy ending. We're almost here to a Friday. Again, remember, if you have any questions, reach out. But I've already said that. And by this time, hopefully you haven't looked at the spoilers, because you're going to find this out whenever you graph it out on your own. So I will see you guys tomorrow. Have a good day.